Let's chat about continuous integration. Um, so, like all good software engineers, we're in the business of automating things. Eventually, I guess, automating ourselves at some point, and losing all our jobs, just working our way out of a job. So ideally, we see things that are manual, that are repetitive, are repeating, and we love to automate things, right? We identify what things can be aggregated, can be generalized, and then we create systems that automate those processes. So this is one of them. The continuous integration is yet another system that, having done it hundreds of times, of committing the source code and testing it and building it and deploying it and testing on the remote server and doing integration testing, doing it manually, we realize that this is a boring job. So, and it's not necessarily, we're error prone. We might not do it as thoroughly as every time we deploy. So ideally, the process of us kicking off some source code that's going to be tested and deployed and eventually going out to production. Ideally, that would be press a button and everything happens automatically, right? So continuous integration addresses this particular aspect of automating the entire software development lifecycle. So ideally, we would be part of some larger system, some cog that are turning. That as we check in software into the source control, it kicks off some very sophisticated process that automatically runs some tests on our source code, builds it, does some static testing, does some dynamic testing, and then it deploys it. And if anything happens, anything wrong happens in the halfway through the process, it blames somebody, right? It's either your source code or somebody else's source code broke the build. Now the time from that this happens of when you submit a piece of source code and by the time next time this whole thing is built, the longer you wait between the time of building once and then maybe a week later or 2 weeks later, the longer you wait, the more chances are that you have introduced errors into the system. Okay, not only you, but you are only one in a team of 5, 10 other folks, and you're only one team in a group of 10, 20 teams working on the same system. So there are way too many moving parts, and oftentimes we try to minimize the time between each one of these cycles, right? Of deploying, building, testing. In one of my jobs, it used to be, just every 3 months, right? We made a lot of effort to bring it down to every month. Today we're down to 2 weeks cycles, and we're looking to next quarter to bring it down to every week. But the target would be that we could do deployments just every day, right? That we can just press a button and the whole thing runs all the way down to production. And obviously you work on smaller chunks, right? Smaller, but the errors that you might introduce could be identified also small, that could be treated independently. We're not there yet, but hopefully. One attitude that is usually very common amongst us developers is that we're very focused, keeping our heads down, in front of our particular development environment, our particular laptop, and everything just works fine on my machine. And it's a very common attitude, right? It says, okay, well, it broke the build. Well, I don't care. It works on my machine. And so we need to try and change that attitude, right? That and understand that our machine, right, is only a very small gear in a much larger set of cogs that are all turning at the same time, right? So definitely be open, be understanding that if it just because it works on your machine, that not necessarily is going to work in other environments. So here where we are. We are in our local development environment, my machine, and I have my local database running, and I have my local server running. I have my own configuration files. I have my own environment files, my own XMLs and JSON files locally on my machine. And probably I've went through a lot of effort and trouble to get it even running on my machine, right? And that same effort has to be replicated at higher, at higher levels of, as we promote our source code to additional environments. Here on my local machine, I'm kind of working in a bubble, right, in a self-contained environment. Whereas, as my code is promoted to other systems, to higher level systems, these other systems are being other code is being deployed from my own team. Yes, perhaps we're not dependent on each other, but nevertheless. Perhaps the dependencies are not evident until we both commit to a remote development server. Also, it might be that not just several developers are deploying to the same development environment, but multiple teams are also deploying to that same development environment, right? So it very much happens. It's very common that the remote development environment is often broken, right? It happens that we identify things that we didn't realize locally. But once we feel confident enough that everything's good on the development environment, we feel confident enough that we might promote it to a higher system that's perhaps a QA environment where QA engineers, running their business logics and their acceptance test criteria can start pounding on our source code, on our implementation, and try to find those some errors, some bugs. So in the development environment, ideally, right, we deploy. Ideally, what happens is that as I am working in my bubble, my self-contained environment, other developers are committing to this to their this remote development environment, and I'm getting notifications that so and so has committed, right, changes, and typically what we would do is that to make sure that I'm not so different, or not my changes are not so far off in sync with everybody else's environment, I do a pull, right, of those changes onto my machine, right, so that I could test locally on my machine that somebody else's change has not affected negatively my work, right, so that there won't be any surprises when I check in my things, right, and would break somebody else's work. Yes, right. It's very, very common that any one person doesn't entirely understand the overall system, right? That we have to bring everything together onto a machine to really exercise and make sure that things are indeed not broken. So the remote development is ideally we wouldn't break it, right? That we would test everything locally, everybody else's changes, pulled down onto my local machine. And once I feel confident, I can push over to the to remote development. That I've made all efforts, right? That as far as I can tell, the source code that I am deploying is not going to break development. Okay, and it allows us to identify any integration issues with other folks' development. Anyway, so when we're confident enough, we promote it to QA, where QA engineers, run their automated tests or they're also manual, right? They exercise the user interface with all sets of initial states, right? A set of actions, and then verifying that the application ends up in the accepted state, right? Once we're happy with that, perhaps we might have two additional stages before moving it on to production. It depends. It varies from one shop to the next, from different companies, from different teams. Some teams might have environments that are specifically targeted for performance tuning to bang on it with a lot of queries to see if it performs on heavy load, and then promote it to a staging environment that is the closest thing to production that we might have, where perhaps from time to time we bring the state of the production environment, we bring it down to lower levels, where we copy the database perhaps, right? New data has been accumulated over the couple of weeks, right? So we try to bring back the data in the production environment down to staging, down to performance, down to QA, to try and be as close as possible to the production data, right? Perhaps this might not be realistic. Some of the data might be confidential. Some of the data might be private, and some of the data might not be legally available to developers, right? I shouldn't be able to see other folks' private information, even though I need to test with realistic data. So nevertheless, we try to make the lower level environments as close as possible to production, but it's not always possible to make it identical. So anyway, so every time you introduce code, just be mindful that you're part of a larger cog, and the more commits, the more code that is being introduced between the different integration tests, the more risks of accumulating errors, and the harder it becomes to fix them. I know it was a nightmare when our integration builds were every 2 months. We had humongous amounts of code from different amounts of teams and we had all different number of branches. The fall, the spring, and it was just a nightmare, right? To reconcile changes. Sometimes you had to cherry pick which commits were going to end up in what branch. It was just awful. So today has become much more simpler. Smaller commits that we can at least during the end of the week we can understand what's actually going into the release branch and eventually into production, so that we don't have to work over the weekend to try and fix this. It all usually starts either at the code repository or even at the when you are assigned a task and in a particular sprint, and you decide that you're ready to start working on it. So that might actually be the kickoff of this entire process, right? When you in Jira or whatever tool you're using, when you say that you are in progress, oftentimes these SDLCs pipelines are configured to automatically create a branch for you, right? Usually with a default name, right? And you need to start working on that particular branch, right? It automatically pulls the latest from master, automatically creates a branch for you tied to the task that was assigned to you, right? Because ideally we would like to be able to follow, right, the history of all the work that we're doing, right? So this was assigned to you, it's in progress. We see the branch that was created, that the work that you do, any new files, any new modifications are on that branch. So you could see, right from the ticket or the task that was assigned to you, which source files were touched, what work was actually done, which tests were actually created for that particular task. Once you create a PR, that would then kick off many other events, right? They would kick off all sorts of tests to do static analysis of your code, right? Whether checking to see whether you have code coverage, that your tests are considering all the possible ways that the different logic can be exercised with all your if statements and all the different branches are being exercised. That you're not breaking any stylistic issues. Whether you do single quotes or double quotes or spacing or curly brackets on new lines or on the same line. That you have the right tabs and whatnot. So a lot of this is kicked off when you create the PR and you get a report. Ideally you've done this locally on your machine, right, where you have local tools that run locally and tell you what is your progress of the quality of your source code. But then once you have a confidence and create your PRs, this automatically kicks off the integration testing that then reports on the quality of your code. Why isn't this turning off? And once it passes all the tests, right? Then you get a notification say, "Yep, everything passed. We're ready to merge this and then merge it into master." Ideally, this would again be automated as possible, right? It would be completely transparent to you that as you commit your source code, you can be confident that you could turn around and test it and see if it deployed in dev and do your integration tests in the environment within a half hour or whatnot. Okay, so there are quite a few tools out there that are designed to automate this process. Jenkins being one of the more popular out there, but certainly not the only one, and not the prettiest one either. So basically, it's a tool for kicking off various automating several stages of the build process and the testing and reporting back to whoever is responsible for this, right? And if something fails, it notifies everybody. Say, hey, your code caused the build to fail. Everybody in the team would know, right? It would show which check-in, which check-in into GitHub caused the failure, right? So it would be fairly embarrassing that it is you and it's upon you to make sure that you fix it. Now, oftentimes you're not going to be responsible for maintaining these. There's a whole team, depending on how big your organization is. There might be a team that dedicated specifically for maintaining this for you. An operations team that builds all these scripts and makes sure that all the various versions of the environments are correct, and updating all the Java versions, all the PHP versions, all the Python versions, that all the libraries that are dependent are also installed and whatnot. So if you're lucky, it won't fall on you having to do it, but certainly you should be ready to pick up these skills and jump in if a build dies and the environment is not set up as you expected it. So basically, the Jenkins allows you to create various pipelines that take your source code through several steps or several stages that it will automatically pull from a particular source repository, a particular branch, right? It will run, depending on your configuration, it will run first a build, right, where we'll compile your source code. We'll, if it's depending on your stack, you'll have specific steps, right? If it's Java, it'll create all the classes. We'll create all the jar files or the war files or the ear files that are needed, and it will archive it and put it deploy wherever they should go. If this is a JavaScript stack, it will run gulp. It will run all the uglifiers. It will concatenate all the source code. It will minify it. It will go run all the different steps that are specific to your particular stack, right? That you have chosen. It'll run the unit tests against your source code. Unit tests that you have created, right? That presumably you ran locally on your machine, that they passed on your machine. If they don't pass on the pipeline, right? All the developers are going to ask you, well, didn't you run the unit tests locally on your machine? Right. Well, this is embarrassing. How could it not pass here? Integration tests might be a little more involved, since oftentimes locally, oftentimes you might be building a source code that depends on APIs that are not yet ready, right? That maybe some other team is working on, right? And that haven't yet deployed. So oftentimes you find yourself mocking all these services locally, right? So that you can do your work independently from other teams. And the only time you really can test this is when the other team has said, "Yep, I deployed my APIs and they're ready on the development environment," and you check in also your code, assuming that it's going to be there as well. Ideally, this would have happened earlier, right? That they would have the server-side folks have deployed their APIs, and you have been able to perhaps pull down their source code, run it locally on your machine, and test your APIs against your API calls against their implementation. But again, depends on your particular team. Anyway, it deploys, and hopefully everything goes well. Now the actual tools that it uses to build are dependent on your particular stack, right? So if it's Java, typically we'll be using Maven, or Make or Gradle or Gulp if you're using some JavaScript stack. So it depends. And Jenkins supports all the stacks, right? You can there's plugins for everything, for every conceivable stack out there. And typically you configure it, or some administrator or some deployment engineer will configure it by creating the equivalent of a make file that declares what are the various steps and what reports do you want to generate at the end, and who do you want to notify of the different stages, and the different stages are declared in stages, right? You can say the stage is the build stage, the test stage, or deploy stage, which will be executed in order. Each one of them will consist of various steps, right? Where the steps could be archiving or building something using Maven, or minifying a piece of source code, or uglifying it, or concatenating various source codes into one single file, and then running the tests against those resulting artifacts. And at the very end, depending on whether it succeeded or it didn't succeed, right, it'll notify folks either by email or by text or by Slack, sending messages to a particular subset of the team, right? But again, just to remind ourselves that here we are down one lonely developer machine down over here in the right-hand corner, and once we check in our code into source control, we are kicking off a fairly complex process, right? That is going to automate all this. Otherwise, we would need to do this manually, right? And again, we are too lazy to do this manually, and we are too imperfect to do it repeatedly and consistently every time, right? So a good developer is a lazy developer. We want to automate this, make sure that it's repeatable, that we have confidence in the process, and that at the end of the day it'll do all the right things to build, to test, and notify us of the process, right? And then go on and notify everybody else. If we have committed and the whole thing was successful, then everybody can feel confident that they can pull, right, from the repository something that is quality, and I can embed and integrate with my source. Okay. So first of all, it all starts with version control. Well, I guess not. I guess we should say it all starts with project management, right? Of identifying what actual tasks are going to be working that particular sprint. But nevertheless, make sure that as far as we're concerned, we have the latest code, that we are running tests against the latest from everybody else, right? Merge onto our system, and testing our code against the very latest. So the very first thing every morning you come in, do a git pull, make sure that we have the latest from everybody, merge into our particular branch, right? And make sure that whatever was checked in from last night, that it doesn't break anything of ours, right? Or there's no conflict with whatever was checked in the night prior that does not break our code. And if it does, then we are responsible for handling those conflicts, right? Of why is it that is breaking our. But always make sure never to commit something. Well, first of all, commit as often as possible, right? To make them tiny little commits, avoiding large batches of code, and making sure that we don't commit code that we're not confident that might break. So here's just a small example on a Jenkins file that has been has just some dummy steps here that just echo that they're going through the various stages: building, testing, and then notifying different various folks on whether it succeeded or it failed. So these steps, typically they're going to be using some type of command line to either run gulp or maven or gradle or whatever you would have done you would have typed that command line to build your particular environment, right? It'll do a git pull to retrieve everything from the right branch. It will run a maven clean install to generate the class files, the compiled JVM files, and if it breaks, right, there will be a post configuration saying, notifying folks if something went wrong. So here's an example of using Maven, assuming that your environment is Java, but certainly there's plugins to run, any type of build tool, Ant, certainly gulp, and obviously these would be written specifically for whatever environment you're using, whether it's Windows or Linux or you would have to write the correct command line to build. So then after the build, you can configure it to run whatever testing framework you're using, whether you're using Jasmine or Karma or JUnit or Mocha or whatever particular testing framework you use locally in your machine. it would then also be configured to be run on your remote environments where you're building. In this particular case, we're running the test target on a Maven build POM file, but if it fails, looks like we are nevertheless going forward. Although we're going to notify that something did go wrong and notify everyone of what happened. Now you can configure when things should occur, on whether you want to always execute a particular step, or only when it fails, or only when it succeeds, or if somebody manually aborted the whole process, stopped the build, we can also notify, or if there were any, not that the build failed, but the tests fail, right? Where we want to identify that the system is unstable. It built fine, but then when we ran the tests, some of the tests fail, and we would like to also notify. So, for instance, here we are, after we had run the build, we can configure that we can archive the results in a particular directory, and then notify and Slack some folks on whether it succeeded or whether it failed, and it would send over the details of the failure, right? It's telling what particular commit was responsible for the failure, right? And hopefully it won't be your commit, right? Hopefully it'll be somebody else's, and you're not to blame. So here we're archiving and then notifying, slacking that either succeeded or failed, and that's the Jenkins file. So presumably this has been configured for you. Our TAs have gone through the process of already configuring Jenkins for you. Again, it has been configured to be mostly a J2EE projects. So if you stick to J2EE, you should be all set. But if you want to use some other stack, then you'll need to come back and edit the Jenkins file, right, for your particular stack. All right, but everything has been configured, assuming that you have at least a J2EE environment.